share our Passive House Northwest story with you about our process, research, presentations, and policy efforts here in Washington State. I gotta say, I love the premise statement for this policy summit. All new buildings can and should be Passive House buildings right now. And we did not have this bold accelerator statement when Passive House Northwest thought about becoming a player in the policy game back in 2017, but we were thinking along similar lines. Our goal became this: to create an energy code pathway for all new multifamily buildings to meet the PHI low energy building standard. A typical code cycle brings small incremental steps of improvement represented by the blue arrow. Getting to a Passive House certification level overnight, the yellow arrow, while technically feasible, seemed too high of a wall to scale for us in just one jump. Pushing to the low energy building standard felt attainable for getting our state to a Passive House certification point. And if it proved successful, it would move our energy code from sitting 4 code cycle blocks down the street to standing right on the doorstep, ready to knock on the door to a full PHI or FIAS certification. Just a quick side note, FIAS plus 2015 standard ranged from 4.9 to 6.4 for heating demand, depending on the location. EnerFit ranges from 6.3 to 7.9, depending on where in our climate zone for the state. And at one point, I did have a slide that showed all 4 of these together, but it's just too much information in one place. I'm going to spare you the deep dive into the 20-some individual measures that were modeled on a 4-story and 10-story multifamily prototype buildings. But the takeaway was clear. There is no individual measures that by themselves come anywhere close to meeting our target heating demand. And just a quick note to help folks calibrate, our commercial code uses CFM 75, our residential code uses ACH 50. Our current commercial code at 0.40 CFM 75 is approximately 2 ACH 50. The Army Corps of Engineers standard at 0.25 is 1.2 ACH, and the FIAS 0.08 standard is 0.4 ACH. So what did work was a combination of airtightness, heat recovery ventilation, and insulation. So that's no big surprise for folks who know Passive House. And at this point, I started sharing the model results with a friendly stakeholder group. The group seemed quite okay with the additional cost of $1,400 for each unit, which would be recovered by energy savings in about 5 years. The big surprise came from an affordable housing rep who expressed extreme concern and would not support the proposal when I mentioned the performance met the PHI low energy building level. This friendly group also suggested breaking this package up into individual proposals. Airtightness by itself could pass, but the heat recovery ventilation was just doomed to certain failure. So I did listen to that group, but decided to keep everything bundled. Certainly a risky move in code proposals, but we were going for low energy building status and not incremental. Note that I did drop the insulation from the package, which meant I could go back and accurately tell the affordable housing rep the proposal was no longer at a PHI level, and that did gain their public support. What I kept to myself was that a similar insulation proposal was very likely coming from some other organization. So beyond the geeky model numbers, there were 2 things that really jazzed me up about this proposal. First one was balanced heat recovery ventilation. This is, to me, is a big win because it means eliminating trickle vents from window frames, because this is not ventilation. The second was airtightness. Leaky buildings, they just irritate me. The fact that air can leak in from joint cracks and be called makeup air is it's just not right. To emphasize this point, I'm going to do something a little bit unconventional in presentation, and I'm going to quote myself from 2015, but hopefully it explains why I feel airtightness is so important for indoor air quality. Now, if I feel like I need fresh air, I do not want to get down on my hands and knees to snort a line of air along the top of the baseboard trim. So with our research and outreach complete, it was now go time for presenting this to the State Energy Code Technical Advisory Group. I introduced this as a proposal from Passive House Northwest and never mentioned Passive House again. I emphasize that if you set a standard, the industry will learn to meet it. And in this RDH report, more than 3/4 of the buildings tested met the Army Corps of Engineers standard. And building tests in Washington State were also showing the ability to meet this standard. The option airtightness level that was proposed was also achievable. This Walsh construction list shows a dozen buildings they have hitting and exceeding the mark down to 0.012 CFM75. I emphasize that mechanical ventilation is absolutely essential for multifamily buildings. In this RDH study of a 6-story building with trickle vents, the upper 3 floors consistently are above the ASHRAE standard for CO2 concentrations. And when you overlay the Harvard School Public District Health Study, 2 of the 3 lower levels were typically above a level corresponding to a 50% reduction in cognitive function. And then another 2 floors, while they did meet the ASHRAE standard, had CO2 levels corresponding to a 15% reduction in cognitive ability. So what the combination of excellent air tightness and balanced mechanical ventilation does is provide exact control over where air is coming from. And a study from Stephen Winter Associates shows that turning on an exhaust fan in an airtight building creates a pressure response. When a door is opened, the pressure drops in stage 4, and we know air is coming in through the door. The same situation in the building that was around our current code airtightness, when the exhaust fan is turned on, and there's essentially no pressure drop happening. And when the door is open, there's minimal pressure drop. So this means air could be coming in through the door, and it just means it could also be leaking in from holes elsewhere in the building. And a real life example of this is when I was punch listing one of our affordable multifamily projects in California with the client's maintenance manager. In one unit, I reach in to turn on the light in the bathroom, which is right across the entry hall from the kitchen, when at the same time he's turning on the kitchen exhaust fan. And air blew across my hand. And I yelled over, "Turn off the fan, turn off the fan." And so following a very strange look, he turns off the fan and the air stops blowing across my hand. And then I'm like, turn it back on, turn it back on. And again, air blows across my hand from the light switch. So we traded places so I could show that I was not completely insane. And when air blew across his hand, the stunned amazement and his burst out of laughter was just priceless. So on the other side of this open living space, about 20 feet away, there's an open Z duct in the exterior wall where outdoor air is supposed to come in from, but instead, air was leaking in around the light switch. So now I need to update my baseboard line. So, hey babe, you okay there? Yeah, I'm fine. Just getting a little fresh air from the light switch. So healthy indoor air is a basic human right. This was stated by the World Health Organization in 2000. I ended this Energy Code Technical Advisory Group summary presentation that this proposal was achievable right now. It improved the comfort and health of our fellow citizens. It was extremely cost effective and provided excellent energy savings. And I concluded with that this proposal was an essential next step for the state on its path to meet the required 70% reduction in energy use by our 2030 code when compared to the 2006 code. So this proposal did pass the technical advisory group as it was written, bundled together. I ran into a little opposition at the final state code council hearing, but it survived. And after 2 implementation delays, our 2018 energy code went into effect on February 1st this year. So that separate insulation measure did get proposed and did pass, and that effectively completed our Passive House Northwest proposal. So what is not well known is that the multifamily prototype models do show that heating demand is low enough to meet the low energy building standard in the prototype models. It gets even better when you up the heat recovery to above 80% if you select that as one of your required 6 option points. So just a note to say that I want to emphasize that this is not a prescriptive approach. It does not guarantee every multifamily building will meet the low energy building standard. Teams still need to select the air tightness option, model their buildings, and make smart decisions to meet all parts of the standard. And just one quick note about Shift Zero in our area. This is a coalition that was co-founded by the Northwest Eco Building Guild, AIA Seattle, and Passive House Northwest, with the idea that environmental organizations should stop fighting with each other and instead work together toward creating a zero carbon built environment. So now we have over 45 organizations in this coalition. And just 1 year later, when the proposals were due for changing the state residential energy code, Shift Zero made this proposal to the state to list PHI and FIA certification as one of the energy code compliance tasks. And this is now also code in Washington State. So to end, there is no substitution for being in the room where it happens. To suggest work to get yourself and your allies into the room, making those new proposals, get yourself appointed to boards and committees, and become part of those folks in the room who do make decisions and give approvals. So with that, thank you, Passive House Accelerator. It's been a pleasure to share our Passive House Northwest story with you and our persistence and under the radar proposal to create a path for all multifamily buildings in the state to meet the Passive House low energy building performance level. Thank you, Zach.